So my agenda today, we're going to just talk about some of the factors impacting feed efficiency, go through some basic economic calculations. We're not going to do a 10-page spreadsheet, so you'll be okay there. We'll work on that later. Then we're going to talk about some of the things, some of the observations, just some of the things that we see out there in capturing feed efficiency improvements. So first thing is here, how do we measure feed efficiency? Pretty basic thing. I mean, Noel talked about caloric efficiency and converting those across the species and making sure you're calculating everything right. Well, we see when we benchmark things, closeout feed efficiency. Here's the definition here: total feed delivered, weight sold minus weight placed. Doesn't take into account dead pig weight. And I've seen across different record systems, it's becoming very standard, I think, much more so now, but different systems don't include culls, some include culls. How do you calculate feed efficiency? It seems like an easy number, but it's a lot more complicated than it ends up being. And so my key point there is if you're comparing across production systems, make sure you understand how it's calculated. Sometimes it doesn't matter, just as long as you're looking at the differences and they're calculated in a consistent manner, if you're doing some benchmarking. The other thing is, from a research standpoint, from a nutrition trial where we have small pig trials and we have for example, we have a pig die in the finisher, we have a 5-pig pen or an 8-pig pen, and one dies from a torsion. Well, that's unrelated to the treatment. If you don't count that pig's gain in there, it just really messes up our interpretation of the data. So how you calculate that feed efficiency depends on what you're going to do with the data as well. Which group has better feed efficiency? Closeout A, closeout B with a 2.84. Mike, which one's better? 284. Hey, this guy can count. He knows lower's better. All right. Give him a bonus there. All right. Get to looking at things. I think Noel alluded to this as well. Going to heavier weights. You can see closeout A, 25 to 127 kilos or 55 to 280. Closeout B, 50-pound in weight, 250-pound market weight. Actually, we go in there and we adjust things, and these were closeouts that were fed the same diets, so they're the same caloric content, same nutritional program, and you can see when we adjust for weight, this one's got this 2.9 ends up being about a 2.84. When we adjust here on a weight-adjusted basis, the 2.9 adjusts down to a 2.73 when we adjust it down to a 50 to 250, and our 284 stays there at a 284. And so really from a feed efficiency, and in this production system, when you're comparing closeouts and looking across growers, and just because of flow or something and the grower didn't have any control over when or where, you can see that closeout A is actually has less feed wastage because we adjust it for weight. And so body weight has a big impact on feed efficiency. And you can see this from I took this out of one of the PIC tech memos from where they have a nice set of growth curves. And you can look at this. This is just, I just took part of this table. You can see here we've got body weight going down here, and then we've got feed intake over here, and cumulative feed intake. And here it's in pounds, here it's in kilos. We can see if we went, this is the same growth curve, 64.5 pounds to 270, we'd have a 276 feed efficiency. Here if we took them 77 to 304, or 297, I'm sorry, 304 kilograms of feed, 3.05 feed efficiency. Same exact growth curve, same pig, we're just going to heavier weights, And so you can see this is a case where lower is exactly the same as higher on a body weight basis if we're going on the same growth curve. So some of the things that we always try to look at, you got to figure out what you're doing to compare your feed efficiency. Are you benchmarking with another firm? Are you benchmarking producers, growers within your system? You always got to look at weight in, weight out, grain source. Milo diets. Milo's got about 96% of the energy of corn. We can usually purchase it for about 88 to 90% of corn. So even though the feed efficiency is a little poorer on Milo, the feed cost per pound of gain is going to be better. Of course, added fat, added energy, meal versus pellets. Pelleting diets lowers feed efficiency. So if somebody's feeding meal versus pellets, and then of course if you're comparing across different genetic lines, that's another big factor that affects feed efficiency as well. Looking at the economics, moving in there, just calculating feed cost, taking feed efficiency from a simple biologic number and then just converting it into an economic number. It's just a simple ratio of feed cost per unit of gain. Here we have 250 kilograms of feed, 25 cents per kilogram, 100 kilograms of gain, 62.5 cents per kilogram of gain. Or you can just do it feed cost per unit, 25 cents per kilogram or pound or ton or whatever, times feed efficiency, and you just get a unit measure from an economic perspective of per kilogram of gain. And so when you look at some of the economic scenarios, where we do a simple lower feed cost with no difference in feed efficiency, we just change part of that economic equation. We change the cost without changing the biologic performance. What's that going to do? That's going to be better economics, right? So things like removing ineffective additives or feed ingredient, lowering the cost of procuring grain. That's just going to lead right to your bottom line there. So it's a direct indicator of economic performance since there's no impact on any of the biologic parameters. Now it gets a little more complicated. Now you get the scenarios here of higher feed cost gives you better feed efficiency, or the reverse where you go with lower feed costs, which we've had to do in the last few years, and it goes to a higher feed efficiency because you got a lower caloric density. And this is a case where we're maybe in that late finishing pig that isn't limited on space and is very healthy. So what happens there is that pig, as the caloric density of the diet decreases, his feed intake goes up, doesn't affect his growth rate. So this is a scenario where then if you convert it into, you just got to take the feed cost per kilogram of gain times the expected feed per gain. We've got 98 cents per kilogram of gain. Here where we have our high caloric density times our expected feed efficiency. See, we've got a better feed efficiency, but it took us higher cost diets to get it. And we end up being, our cost per kilogram of gain, cost per pound of gain actually increases. Higher cost diets, lower feed efficiency. This is a case where as long as it's not impacting average daily gain, our feed efficiency is poor, but our economic performance is going to be better. And that's a scenario, we've had to move to in the last few years. Only when you do it, a lot of times, too, from a nutritional standpoint, we go to a higher feed cost, lower feed efficiency, and with a higher average daily gain. Now we add, not only are we changing feed efficiency, we're changing average daily gain. And now we got a value gain in there somehow. And it makes it way more complicated. Because if you think evaluating feed efficiency from an economic standpoint, average daily gain gets way more complicated and has a wider variety of values across production systems. In a space-limited system, it's going to be a lot different than a space-long. And so this is a case where when we have, in like a grower pig, or even to some of the energy density diets that we're going to, lower energy density, will probably affect growth rate even in a late finishing pig by lowering energy density. If they can't eat enough feed, Noel was talking about taking 20% more time to eat a diet. And so here, this is a case where we've got 29 cents feed cost, expected feed efficiency, lead to, here we have higher caloric density, and we have a higher feed cost per kilogram of gain. But we haven't taken into account, and people that I've worked with, then when we start changing energy density, I'm always asking them, are you space long or space short? Isn't that right, Tyler? How many barns do you have? What's your market weight? Where, you know, how are we, what are we doing marketing pigs wise? You know, on a fixed time system, especially if in like some of our shareholder systems where they get pigs every 8 weeks, it's an 8-16 week. If we slow that growth rate down dietarily, basically we're going to drop their market weight. And so if we drop their market weight, now we've only got 17 kilograms of gain. And in this case, even the feed cost, lowering the feed cost and lowering the revenue, we actually come up with a higher income over feed cost. In many cases, this will value gain to a high degree. We've got this fixed time system, and especially if market prices are really good. And so now we've added all these other factors in there where we're valuing gain. We've got different systems value gain differently. We've got different market prices that vary. And so in this case, again, we've got lower caloric density, lower feed efficiency, but we've actually got a better income over feed cost or a better indicator of profitability. And then, you know, we talk about space long, space short, going to a fixed weight versus dropping market weight. Here's the economic calculation where you look, you got to take into account the days. Here we've got the same kilograms of gain, different feed costs because of the different feed efficiencies, but now it requires more facility cost because we've got to extend that average daily gain. And so we're talking income over feed cost now. Our disparity here where we've lowered feed cost, if we've got excess facility space, our income over feed cost is even higher here with the poorer feed efficiency. So economic numbers there. Other considerations, you know, these can get into valuing the rates of protein and fat deposition. We talked about residual feed intake and changing that carcass composition and in back fat and how you get paid. Or does it really matter? Like the new Smithfield grid that doesn't have any lean in it. You know, is there some economic value there? Or alteration of yield. Basically, you know, typically we calculate feed efficiency on a live weight basis. Your feed to gain is there. And now we're feeding a lot of ingredients that decrease yield, and so we got to feed to a heavier weight to get the same carcass weight. And so it's going to take us a little more feed, and again, Noel talked about carcass feed per unit of carcass weight gain. And I think that's what he's getting at there, is trying to take into account if we're feeding these different feed efficiency, different ingredients that affect yield. And Joel and his grad students at K-State here in our group, we're trying to do some studies to predict yield so we can put it into an economic model and figure out how much extra feed does it take when we feed some of these lower energy ingredients. And we talked about the payment value or even maybe you're getting paid on wholesale cuts, and so we change the composition of those. And so what we do from an economic standpoint, we try and develop some simple models. I mean, we use a lot of spreadsheets. I don't know how a pig farm would operate without spreadsheets, huh? You know, and you know, I teach a class where we use a lot of spreadsheets, and I came across an article that says over 60% of spreadsheets have errors in them. And we make a lot of decisions with spreadsheets. So relating it back to the talk this morning, a little overconfidence in our spreadsheet modeling there sometimes. And then there's, you know, all the way to the growth simulations. That's where some of the genetics work is coming to, is trying to indirectly measure some of these feed efficiency parameters through growth simulations. The OSPIG model that's been around for a long time, it's trying to take these biologic things and translate them into an economic scenario. So feed per unit, again, it provides a gross indicator of profitability, but when you dig down into the nitty-gritty and the specifics of production systems, lower isn't always better there. And so you need to implement, my key point here is you've got to do some more sophisticated modeling when you're working with a specific production system to get at those economics. Just as I wrap it up here, the next few minutes, we'll try not to hold you for lunch. Just some practical things, some observations working with production systems when we're tackling feed efficiency. Reducing feed wastage, you know, that's a minimal marginal cost usually to reduce feed wastage. So minimal marginal cost, high return, you know, the return on investment from minimizing feed wastage is huge, you know. A finisher feeder with two 25 pig pens, there's about $12,000 worth of feed going through there a year. And I'm pretty confident that that number is pretty close because this morning Joel DeRushi was going through a slide set that John Bergstrom, anybody know John Bergstrom who got his PhD with us? He's kind of a detail person. John had $11,925.32 in his slide, and I just rounded it off to 12,000. So that's kind of a reflection of our personalities. John's a little more detail-oriented than I am. But anyway, I'm glad they agree anyway. So, replacing feeders. And this is one that I'm guilty of, I think, as a nutritionist. Probably haven't emphasized enough on feeder design and just not, when I work directly with production systems, over the last couple of years, we've done some feeder studies and those kind of things and started actively just trying to get rid of crappy feeders. And it's just in production systems, you know. And when they make these stainless steel feeders that last forever, you know, when they never wear out, even though you're wasting 10% of the feed, nobody wants to just take those things out and throw them in the trees because they're just too good, you know. We're too thrifty in the pig business. But one turn of pigs and those things would pay for themselves. How about this one? 40,000 sow farrow to finish system. One handful of feed per feeder in that system is about $1,200 a day. One handful of feed per feeder. So, big deal there. Particle size reduction. You guys have heard the K-State group, you know, our milling group. 1.2% in a corn. This is in a corn soy. We're doing some research on DDGs to see if we're getting the same response. There's some evidence there that taking DDGs down might help improve digestibility as well. You know, each 100 microns is 75 cents to $1 a pig. And again, that's money going right in the pit when we've got high particle size. And we've got producers going 500 to 600 microns in pretty large-scale production systems, making it work really well. You know, feed technology there, I think there's a huge, huge area from the ability there. Some of it's on how you measure. Now, some people will claim they're at 350, 400 if they're using a flow agent, you know. And so again, we get into that measurement deal, don't we, Neil? It's all how you measure things, too, and compare yourself. Genetics, growth rate, feed efficiency, lean, relatively easy to measure. Other traits, meat quality, survivability, and the survivability impact on feed efficiency. Those are kind of difficult things to get at, quantify. Health, the implications of changing health of sources and the big impact that has on feed efficiency. Our general observations are that investments in genetics to improve feed efficiency is usually a pretty high return activity. Actually, I should have asked Noel there for a little check to giving him a plug there on the genetics side. But unfortunately, you gotta start with a good genetic base, and then we gotta feed them right. How's that? All right, nutrient requirements. The big key take home here from a feed efficiency standpoint. You know, our era of feeding, it used to be you feed to biologic maximum and just a little bit over that, and you were pretty close to the economics. That was economic optimum. It's not the case nowadays. I mean, we've got to feed a lot lower energy diets. I mean, we're talking $3-4 a pig in many cases going to lower energy diets. So, and we see this around the world. We're seeing the same thing. And then you get into the really significant capital cost feed processing like pelleting. You know, there's all kinds of people now. There was a move away from pelleting for a while, and now there's all kinds of people, you know, trying to quantify that. And we've just recently done some trials. There's some other trials there. Capturing that feed efficiency advantage is highly sensitive to the quality of pellets that you make. And so talking about calculating the economics of a pellet mill, my head hurts when I start thinking about it because it ends up being what numbers you plug into the model. So just to wrap it up here quick, is lower always better? And how's this for a university professor answer, huh? Does that keep me there? Is that right, Gene? Typical? All right. It depends. Yeah. Depends on your specific situation. You know, and that's what I really like about working with. I work with a handful of producers just from a practical standpoint, and getting in there and digging in and figuring out those numbers is what's a lot of fun. So